Sir, with your permission, can we start, sir?
Yeah, sure.
A very good morning to all. I just welcome you to this last session of the 2 weeks refresher course on data analysis using statistical methods. For this last session, we have with us Professor Surendra Kumar, who will be talking on the topic econometrics of project evaluation. Sir, at present is the head and dean, Department of Economics, Delhi School of Economics, University of Delhi. Sir has been a part of this institution for last 7 years now. Sir has done his PhD from Jawaharlal Nehru University in Environmental Economics and his postdoc from University of Illinois at Urbana-Champaign in Environmental Economics only. Sir, in the past has been faculty in various institutions like Terry University, Yokohama National University, Yokohama, Japan, NIFP, New Delhi, Project Postgraduate Arya College, to name a few. His areas of specialization are environment and resource economics, climate change and energy economics, applied econometrics, efficiency and productivity analysis, to name a few. Sir has been teaching in last couple of years the different subjects like applied production analysis, environmental and resource economics, climate change economics, advanced econometrics, energy economics, economic analysis of public policy, sustainable development, and business executive education. Sir has organized executive number of executive training programs and faculty development program. Uh, some of them being like business and the program on business and climate change under University of Terry, New Delhi. Also, sir has coordinated a refresher course in economics in South Campus, University of Delhi. Sir has been, to his credit, has a number of books and research articles in different indexed and peer-reviewed journals. Also, sir has a number of papers presented in different conferences, both national and international, to his credit, and a number of chapters in the edited books. We welcome you, sir, to this session, and really we are grateful to you for being a part, for agreeing to be a part of this refresher course as a resource person. And I'm really thankful to you on behalf of TLC Ramanujan College and Indian Accounting Association NCR chapter. It was very nice of you to agree to accept our invite of being the resource person and share your knowledge, immense knowledge that you have with the participants of our refresher course. Now it is over to you, sir. Thank you.
Thanks, Dr. Gupta, for your kind word. And in this session, what we are going to talk is I'm not going into this hardcore mathematics of program evaluation, but in general, what is the idea behind that and how we should go. Just an introductory kind of talk I'm going to deliver in this. And please feel free to interrupt me at any point where you feel there is need of interruption in that. Okay, so let's start with your own example in this talk. And as you are attending this course for the last 15 days, you are here. So what you are going to get from this course, how you can evaluate this question. And similar kind of questions we face when we are analyzing either a policy question or a project or program questions. These kind of questions we face day to day, or especially these days you may be listening about these vaccinations, they are coming out, and before that there some trials were conducted, and what kind of these trials, what they involve into that. So all that we can fit into this framework to analyze this efficacy of these vaccinations. Similar way we can talk about these policy questions in that. Okay, so in this talk we are just going to talk about on those issues. So in that sense, what we can say, this program evaluation, what it mean by this word. This
So,
word simply, yes,
so sorry to interrupt you, sir. I just want to know, sir, can we have the questions at the end of the session, sir?
yes, you can do that.
So I just request all the participants that at around 11 o'clock, because the session is concluding at 11:30. So I request the participants to put their questions in the Q&A box between 11:15 to 11:30 so that the same can be taken up by sir with my help. Thank you, sir. Sorry for the interruption, sir.
Okay, so means what we mean by this program evaluation. Program evaluations means here we are talking about measuring the effects of a social program on the society rather than on individuals. And it is a method in that way of collecting evidence for policies and programs. Because when we are talking about this kind of framework should be there or should not be there. So what is the evidence for that? Or alternatively, we can say this kind of framework help us in having evidence-based policy making rather than just you can say this intuition based kind of framework. Of course, every time we don't have the evidence, we have to work with intuitions also, but we should try to have this evidence based policy issues in that. Okay, so given that kind of context, so in this kind of framework, what are the questions that we are facing? As we started with that in these 2 weeks programs, you are the participants and how you are benefiting from this program. This is the question that we may face. And similarly, here, when you are participating, you decided to participate in that, this, you said the communication from the program, it went to a lot of people, not only to you, but only a few of those are attending this program or participating in that programs. Okay, so here again the question is who are choosing this program to get. For example, say sometimes or in our university framework, what we see that this our promotions they're also linked to this attendance or this participation of this kind of programs. So only those people who are participating whose promotions are due, they need the certificates, or there is something else also. And how we can analyze this question and what is the impact in program evaluation of these questions. These are the things there. Similarly, what we can say, and if these benefits of the programs, if they are extended, so how these non-participants are affected by that. Okay, and then this there is heterogeneity among participants also. So how these benefits and cost they are distributed. These kind of questions in this program evaluations we have to face and how they may help us in that. This is the question that we are facing and that we may understand more by this simple figure. And here what you may see that there is this you can say a line which is showing the benefits program participation or the initiation of this program, any program you can say, there is this kind of path. And at some level, there is some kind of intervention or this program is there or some kind of policy is introduced. Okay, for example, say that during this pandemic, this government introduced certain kind of, you can say this stimulants, that period, we can say this is that kind of period. And then after that, there is this kind of progress is there. Okay, so generally what we used to say that what is the pre-program outcome level and post-program outcome levels. These two things we try to compare, and the difference we can say it is the program
Dr. Purushottam, is there any problem on my end, or it is not audible?
I think we lost connection of.
Acha. Oh, he'll join because there's a lot of weather problem today in Delhi. So
Yes,
that may
yes.
be the reason. Our apologies to all the participants. We have lost connection with Professor Surinder Kumar. That's why his voice is not audible. I request you all to be patient. We'll be coming back. My voice is audible,
Yes,
Purushottam?
yes, ma'am.
Purushottam, am I audible?
Yes,
Yeah,
ma'am.
yeah. Because we have a very bad weather today in Delhi, so that's why there is some problem in the connection there. Yeah, sir has sir has not. Thank you, sir. Good morning, Charu.
Good morning, ma'am.
Sir has
Morning, sir.
Sorry,
Morning, ma'am.
maybe something went wrong.
sir, not an issue, sir. We know that there is a very bad weather today, so network problem may be there.
Yeah,
Mehpara, sir, good that it is snowing in Kashmir, so we can have some snow in Delhi too.
yes.
Thank. So one of the participants we are having from Kashmir, Mehpara sir, he's saying that it is snowing in Kashmir. So that's what I'm saying, sir.
That's
That,
good in that sense.
ji sir. Sir, please continue. Thank you.
So we are talking about this figure. So here we are saying that before this program, this kind of outcomes were there. Then there is program intervention. And when we are analyzing, we are at this level of the outcome. Something like this, we can see. Means we are saying before the program, this is the level of the outcome. Then there is this program intervention is there. And when we are evaluating, or you can say at the end of or the post program, this is the level of the outcome. And in general, what we say, this gap, this outcome level, pre-program and post-program, these two figures we compare, and then we try to say that this is the result or outcome of the change. Outcome change we can say. Okay, but is it correct? No, because even in the absence of the program, as we started with the example of this program participants, their research activities, this teaching and research activities, even in the absence of the program, they have to continue to grow. They have a certain path, but due to this participation, there may be some impact. It's not that because of this program, all impact is that. Okay, so we can see in the absence of this program, they may have this kind of path. Okay, so in this situation, the program effect may be only this much. So how to get this part, that is our main concern. Rather than just comparing outcome pre and post, which generally we used to do, that is not this, we can say the project outcome. Project outcome is only this small part, and how to separate it out, that is our main question that we are facing. And today's talk, I'm just going to give some introduction to this frame. Okay, okay. So here, what we can say. So we have to have a causal hypothesis in that. Means this program is there, and due to this program, there is going to some effect of that on your research and teaching activities. Okay, so that's why in general terms, if we say that we have a treatment, a manipulable treatment, we easily can manage that kind of treatment is there, and that can be applied to a subject, and an outcome that may or may not respond to the treatment. Means we can say this program is there, this program is applicable on some people are participating in that, and as a result, outcome, if we are measuring in terms of your research activities, so some of the participants may have more research activities due to this program, and some may not have. Okay, so that's why some may respond and some may not respond to the treatment. Okay, it is necessary to be able to subject it to a meaningful test. So that's why there is impact or not. We to measure it, we need to have a meaningful test. Some kind of concrete test is required. Such a test requires that all other determinants of the outcome can be held constant, so that the effect of treatment can be isolated. Means here, as in this figure, we were talking about, this is the impact, total impact over the period of time, pre and post. But all this is not the program effect. Program effect is this much. So how to isolate this effect from this total effect? And for that purpose, what is required? As in your classes, you may be teaching day by day that other things remains constant. So how to keep these other things constant? That is the main question. Okay. Okay, this is our main question, that this const how we can hold everything else constant in that. Okay, and here the problem is that if we have to measure this impact, keeping all other things constant, what we can say that, again go with this same example, or later on we can take some more other examples to understand. Here, if this A person is attending the program, then what is this research outcome of the participant at the end of the program? And we have to compare the research outcome of the same participant if these participants have not participated, if have not attended this program. We have to compare this. Only then we can say all other things we are keeping the constant. If we change the individual, that means the all other things we are not able to keep the constant. We can keep all other things constant only if there is the same participant, same individual. But for the same individual, it's not possible to have these two situations. We have the outcome of the participant, if the participant have participated, or if the participant have not participated. We cannot have the outcome for the same individual in both the scenario. So that is the fundamental problem of the causal inference. It would be feasible to simultaneously observe the same subject in the states of the world where it received the treatment and it did not receive the treatment. This would guarantee that all else is held constant. Of course, it is impossible to observe the same subject in both states simultaneously. And this is the fundamental problem of causal inference, or you can say policy or project evaluation. This is the fundamental problem. Okay, so how to overcome this problem and why this problem is there, that we have to understand. Okay, so let's have an example of this air pollution and health. And excuse me, because I'm taking this example from my areas of interest. Okay, so here for simplicity, we can say air pollution is there, and we know this air pollution is associated with health impacts. This kind of intuitive idea we have. Okay, and for simplicity, what we do, we take two scenarios. In one scenario, this air pollution exposure level is very high, and in the other situation, this air pollution level is low, exposure level is low. These two scenarios are there, and the general perception is what? If the person is exposed to a higher level of pollution, there are higher health impacts. Okay, so this example we do take it that to understand this concept, and that's why what we are doing, if the person is exposed to higher level of pollution, then there is an outcome, and that outcome we are saying is this Y1I. For individual I, if individual is exposed to higher level of pollution, the outcome is Y1I. And if the person is exposed to low level of pollution, then the outcome is Y0I. The ith individual's outcome is Y1I, if the individual is exposed to higher level of pollution, and the outcome is Y0I if the individual is not treated or exposed to low level of pollution. Okay, so here what we can say, our interest lies in what? Getting the difference between these two outcomes. Our interest lies in understanding these two, which is the effect of the higher level of pollution relative to low level of pollution. Okay, but here, since this ith individual either can be exposed to high level of pollution or the low level of pollution, the individual cannot be exposed to both level of the pollutions. That is the fundamental problem. Okay, since this difference is not constant across individuals, it is standard to focus on average effect. Because here it's not question of individual for the society, and society comprises these heterogeneous people. So that's why what we do, this difference is not constant across individuals. That's why we are talking about an average treatment effect, ATE, average treatment effect. For clarity, we let D represent treatment status, means person is exposed to higher level of pollution, and D equal to 1, say person is exposed or treated, and D not, we can say person is not treated. That kind of scenario we take. Okay, so what's our interest? We would like to know this average causal effect of the exposure to a high pollution concentration among the treated. Means we can say this expected value of difference in outcome for treated persons when this person, and this fundamental problem of this causal inference, that's bind here, because it's impossible to observe the same individual simultaneously exposed to both the scenarios. We can say either the person is treated or not treated. The same person we cannot have in both situations, that it is treated and non-treated. Okay, so another way, what we can say, every individual has two potential outcomes, but only one is observed. Both outcomes we cannot observe. This is the problem. Okay, so in practice, what we do, as we have seen in the figure, what we do, this is the expected outcome of the treated, and this is the expected outcome of non-treated. That simple difference we take. Okay, sometimes you might have seen that, for example, say, right now we can say this uptake in economic activities. Is it the impact of, you can say, this government policies or not? If you have to analyze it, how you will do it? Because now whatever we are observing, that is the post policy. If in the absence of policy, what could have been, that we cannot observe. This is the problem. Okay, so what we do to understand this part, or to isolate this policy impact, what we need to do, what we are doing here, adding and subtracting the unobservable quantity, this expected value of outcome in a situation for these treated people if they are not treated. Here in this equation, what we are doing, we are adding and subtracting the expected outcome of the treated if they were not treated. Okay, so we are doing it. In this equation, you have added and subtracted this term. Okay, so when you do so, then you have this equation. So in this equation, what we can say, this is our first term, which we can say the impact of this Sorry, again it's happened. Okay, so what we are doing in this equation, which is just measuring this outcome of the treated and the outcome of non-treated. That is simple difference, but our intention is to get this part. Okay, so for that purpose, what we are doing is this outcome of the treated, if they were not treated, that term we are adding and subtracting. And so as a result, this first term is what we are intended to get. Okay, but the second term is also existing there, which is the cause of concern. The second term is known as the selection bias, and that is creating all this problem. Okay, and our objective is what? Our objective is to make the second term is to make it 0. But how we can do it, that is our main concern. Okay. Okay, and the typical way, because in your this 2-week course, you are doing a lot of lectures on this regression analysis. So can we use this regression analysis to understand it? Okay, so the typical way of learning about this validity of causal hypothesis is what? Is that that most of the times, rather than this experimental data, which is very rare, what we have this observational data, and what we do, we fit regression analysis into that. Okay, and in most of your regression analysis, what you do in our conventional econometrics classes, there our objective remains generally to understand the structure of the model. There is a dependent variables, and what are those variables? We try to identify which can explain the variation in this dependent variable. That remains the concern of most of the regression theories in that. Okay, the same framework if we apply to understand this causal inference, we can do so, but we have to hypothesize our question slightly differently. So here our question is not to understand the variation in dependent variable explained by a lot of independent variables, but our concern is to understand the variation in y that is caused by a particular variable, so that this causal relationship we can establish. Okay, and when we are establishing this relationship, we are fitting regression analysis using this observational data. Okay, so here what you can say, this yct, it is your dependent variable, and this tct, it is your, you can say, the causal factor. Okay, so in this example, we can say YCT are the health outcomes, and this TCT is the higher level of pollution, and we are saying this is a categorical variables 0 and 1. We are saying 1 if the individual is exposed to higher level of pollution, and 0 if the individual is exposed to low level of pollution. Okay, so our objective is to establish causal relationship YCT and TCT, and there this theta can explain this causal relationship if we are able to control for this selection bias, or you can say these other variables, which we are saying they remains constant. Okay, so for that purpose, what we are introducing, this x prime ct, these variables we are inducting in this equation. Okay, but what we know, we also know that this exposure to the pollution, higher level of exposure to the pollution, it's also linked to the same control variables. Means what we can say, there are some variables like income, health status. This income is determining health status of the individuals, and this income is also determining the level of exposure. Generally what we observe, these poor people, they used to live in more polluted areas. Okay, so there are some confounding factors. Okay, to isolate these confounding factors, what you do, you have to fit another equations where you are saying this exposure level, it is the function of these other variables. Okay, so here's generally what you say, this expected value of the covariance of t and epsilon is equal to 0. That assumptions we are taking. But here what we are saying that rather than taking that assumption, here we have to assure this, you can say, independence of these two variables, t and epsilon. That we have to ensure rather than just taking that assumption. And for that purpose, you are fitting this other equation into that. This coefficient theta is the true effect of air pollution on measurable health status. The specification of later equation demonstrate that the determinants of health status may also be associated with air pollution. Here, as we have said that this poverty, this income levels, they are determining both your health as well as, you can say, this exposure. Okay, or alternatively you can say, here what you are saying, here you are saying in graphically, if we put this t variable is determining your y, okay, but there is this x variable, this x variable is determining both t and, you can say, this y, both are determined here. Okay, so this kind of graph may help us understanding this relationship. Our objective is what? T to y, this kind of relationship we are trying to fit in. Okay, but there are these other variables which are confounding this relationship. Here this x is determining both t and y. So that's why this relationship is confounding. And the issue is to isolate the effect of the x on y, rather, because there is, this is direct and this indirect effect is also happening. Okay, for consistent estimation, this least square estimate of theta requires this exogeneity assumption that this expected value of the covariance of theta and epsilon is equal to 0. If this assumption is valid, the estimated theta will provide a causal estimate of the effect of air pollution on health. However, if there are omitted permanent or transitory factors, this is permanent factors and these are the transitory factors. And if they are related some way, that this covariance of epsilon and eta, if it is not equal to 0, that covary with air pollution and health status, then this cross-sectional estimates, they will be biased. That will create the problem. Okay. Okay, so that's why this causality question, it is based on these two assumptions. One, the first assumption is that after conditioning on vector of observable variables, the treatment is ignorable. This is the first fundamental assumption. If in this figure we go back, here we are saying if we are able to control for all the variables, then in the presence and in the absence of the project, the effect is very small, it's ignorable. That is the first assumption in that. Okay, this is often referred to the selection of observable assumption. This assumption implies that after conditioning on X, the selection bias is irrelevant, because here what you are doing, we are controlling or for this X variable, and this is the outcome of, for the treated in the absence of the program, and this is the outcome of the program on non-treated in the absence of the program. Okay, so here you are saying that if we can make this effect of the treatment on treated and untreated equally in the absence of the program, if the path of the growth, this growth path it is the same for both treated and non-treated. By controlling on these variables, we are trying to make this selection bias 0. That is the first assumption. And the second assumption is that this effect on treated and non means this effect is one way. This exposure leads to health effects rather than the other way. It's not that the health effects, they create higher level of exposure. So here relationship, we are saying it is unidirectional rather than bidirectional. Here T causes Y rather than Y causes T. These two assumptions we have to take. Okay, and how we can do it, this selection on observable, how to make it this optionalized. To optionalize these questions, we have these different ways of doing it. Okay, so first way of operationalizing this question is the simple linear regressions. We fit a linear regression equation. Okay, in this linear regression equations, we try to control for the variables which we want to hold constant. Okay, for example, say if our objective is to understand the impact, say, of attending a private school or government school on the earning of the individuals. We send our kids to the school, mostly in private schools, with the hope that they will be better off with that, and later in the life they may have higher earnings. So how to analyze that impact? Okay, so here we are trying to understand this effect of the private or public school on the earnings of the individuals. But here, who are going to the public school or private school? We have to control for that. The parents who have higher earnings, those who are educated, they may be sending their kids to the private schools, and those things, this family background, these cognitive abilities of the individuals, they may also affect later on their earnings, whether they are studying in private schools or the public schools. So that's why here what is required, we need to control for those factors using this linear regression equations. Those you can say, confounding these relationships. In this example, say attending a public or private schools and earnings later on in the life. We have to control for all those confounding factors. And here the problem is that identifying those confounding factors is very difficult. It's not so easy. Okay, in general, simple regressions, we say let's control for this variable, that variables, and doing this stepwise regression approach, where we can say if R square is increasing. That's not here the approach. Here approach is identifying all those confounding factors, and that's the difficult task. It's not easy. Okay, second way of doing it is what we need to match this treatment and control observations for all those characteristics which we believe they are common in that. Because here again the objective is what? Objective is to hold all other things constant, to understand the difference between those who are exposed or those who are not exposed, who are treated and not treated, for that purpose. Okay, so here again, because all these individuals, they are heterogeneous, they are not identical. So in that situations, comparing means keeping all these characteristics constant. It's very difficult task again. Okay, third way is that rather than comparing these individuals based on their observable characteristics, here we can also think of the matching of propensity scores. The probability of receiving the treatment condition on vector X means those who are getting the treatment is based on what characteristics. And this approach again offers a solution, but there is this curse of dimensionality. So many dimensions are there. Okay, and that you may also understand when we are talking about these vaccination questions. Those who, what is the propensity of getting a particular individual get vaccinated? Those kind of probabilities also we need to understand in that. Okay, all of these methods share a faith in selection of observable assumptions, which implies that unobserved variables don't carry with both air pollution and health status. Means here we are saying that these confounding factors, this X variable, that in this DAG figure we try to make, that X figures, they are not changing between individuals as their exposure to pollution and health status changes. Okay, so in that sense, what we can say, objective again is to make this selection on observable term of the equation. The second part of the equation is to zero. And how we can make it? This is the question. Okay, and for that purpose, in this econometrics literature, there are various approaches in that. There are these experimental approaches and quasi-experimental approaches in that. And these experimental approaches, they are considered as the gold standard for analyzing this causal inference question. Okay, so there what you do, there we have these RCTs, these randomized experiments we do. And when you are conducting these randomized experiments, there your assumption is what? Assumption is that these other characteristics of the individuals, they are held constant. And how they are or not, that's wait for that. These are one kind of approaches, and the other kind of approaches are these quasi-experimental approaches, which are based on observational data. And most of our social scientists, either in commerce, economics, or whatever discipline you are, there we have this observational data is there. So using this observational data, we try to isolate this impact of the programs. And in that, few popular approaches are this difference in difference method, or this fixed effect approaches are there. Second is this instrumental variable approaches are there. And third is this regression, discontinuity, design as kind of approaches are there. And this all these three approaches, they are based on this, you can say, observational data rather than experimental data. But this randomized experiments, they are considered as the gold standard in causal inference, and but they are based on this experimental data. Okay, so let's have a very brief introduction to all these four methods. Okay, before going into this introduction to these four methods, there also we need to understand these inferences that we are getting using these methods. Either you can say these experimental approaches or non-experimental approaches or quasi-experimental approaches. There we also need to understand what are the threats of the validity of those results that we are getting. These estimates that we are getting, what is the threats to that? There are these three kinds of threats to that: this internal validity threat, external validity threat, and construct validity threat. Let me start first with this construct validity threat. What is this construct validity threat? And here to understand first is what we are measuring. Are we intended to measure that? That we need to understand. This construct validity question is related to the measurement question. Measuring this outcome. The outcome, the way we are measuring, is it the way we want to measure it? For example, say the outcome of this program, you want to measure, but how you want to measure it? In terms that the participants is coming again to the program, in terms of the paper published by the participants, in terms of their, you can say, more paper they are publishing, better research they are doing, in what kind of journals they are publishing. So here, the construct validity question is related to the measurement of the outcome. Are we measuring the outcome in terms of what we want to measure it? Or we are measuring it some way which is not real representation of the outcome. So that is the first question. Because all other things, they are dependent on that measurement. Okay, so here the first question in causal inference, whatever inference you are getting, is whether they satisfy this construct validity threat or not. If this threat is satisfied, then we can say we need to go ahead with that. Okay, so once this is satisfied, means there is some particular theory which is specifying this relationship. If we are able to understand that relationship, then we can say the construct validity question or this threat is satisfied. Otherwise, not. Okay, that is the first question. Second threat related to that is this internal validity question. In the internal validity question, what you can say? Here again, when we are doing regressions, you might have observed that if you change one of the variable, what did happen? Your results are changing. Your results have changed drastically. If you just included or excluded one more variable, your results are changing. Your results are changing if this number of observations is slightly increased or decreased. So here, this internal validity question is related to those kind of questions. If our results, our estimates, they are changing by inclusion or exclusion of one variable or some observations, that means it is not satisfying this internal validity question. The results are manipulatable in that sense. We cannot get the inference in that. As you change the sample size, your results are changing. Okay, so here this internal validity question is related to getting consistent estimates. And these consistent estimates, they are related to your data measurement questions. For example, in time series data, there is this seasonality question. At a particular season, some kind of impacts will happen. So how to isolate those seasonality questions? That's also related to this internal validity. The secular trend questions, the measurement error questions, all these kind of questions of the data, they are related to this internal validity questions. That needs to be satisfied. Okay, and the third question, which we say the external validity question, is that whether your results are generalizable or not. And if your results are generalizable, in what situation they are generalizable and in what situation they are not generalizable. Because generally we cannot have this population. In statics, what we do, we have this sample, based on this sample, using certain assumptions, we try to get inference for the whole population. Are we able to do that or not? If we can do so, then we only can say this external validity threat question is satisfied, otherwise not. So when we are doing this kind of analysis, we should be particular to these three validity questions. Okay, now let's have in brief the introduction of these four methods. First, we are talking about these randomized experiments, which are considered as the gold standard in this framework. And here what you can say is, in a randomized experiment, a sample of an individual is selected from the population. Note that the sample may not be random or may be selected according to observable. The sample is then divided randomly into two groups, the treatment groups and the control group. We have total n observations. These n observations we are dividing into two groups, treatment groups and control group. The treatment group is then treated by policy X, while the control group is not. like in this vaccination questions you may see. Then the outcome Y is observed and compared for both treatment and control group. The effect of policy is measured in general by the difference in empirical means of Y. That means this D cap, we say it is what? This expected value of the outcome for the treated minus the expected value of the outcome for control. As treatment has been randomly assigned, the selection on observable bias is 0. In that equation, the second term becomes 0 because here all these observations means this difference you are capturing based on randomly assigned observations. There is no systematic kind of question is there. So they are all randomly assigned units. So that's why the selection on observable terms becomes 0 in this case. Okay, so here what we are saying that in this randomized experiments, in these RCTs, if we take just the difference in the outcome for treated and control groups, that we can say it is the effect of the policy in that. In simple way we can put it. Okay, but these randomized experiments, they suffers from certain limitations. Okay, first limitations that's related to, you can say, the cost. The cost may be in terms of the financial cost or ethical cost. In the ethicals, which units we should assign to treatment and which we should not assign to treatment, these kind of questions is always there in these RCTs. Always there is some kind of, you can say, these concerns related to ethical questions when we are assigning to the treatment. Whether these treated people, they are well informed about the outcomes or not. These kind of questions are there. So these are all ethical questions in that. Then conducting these RCTs, it is also very costly affair. It's not easy affair. Okay, for example, say if we say our objective is to understand this efficiency of the police department, and there are financial, means you have to bribe them or not to bribe. For bribing you need money, so in that way there are also financial costs, but there are also ethical and other legal questions also. So those kind of costs are involved in these RCTs, that we have to be cautious about that. Okay, then there is this question of internal and external validities. In RCTs also there are this question of internal and external validities. Okay, so as far internal validity question is concerned, that this non-response bias, mixing up of control and treatment groups, these kind of problems may be there. Okay, similarly on this external validity questions, there are these questions of how long these peoples are exposed to that. These experiment specificity questions are there, and even there are these questions of the general equilibrium effects. So these RCTs, they are considered as the gold standard of this causal inference, but they also suffers from these certain limitations. So when one is conducting these RCTs, they should be aware of that. Okay, but our main concern is not related to this experimental data, because of being social scientists, this kind of data is very rare to us. It's not easy to get. And most of the time what we do, we play with this observational data. Okay, this quasi-experimental approaches we are applying. So what are those quasi-experimental approaches and how they work? Let's have an introduction to those methods. Okay, first in that we can talk about this difference in difference estimator or the fixed effect estimators. Okay, so in this DD estimator, difference in difference estimators, what we do means here again we can say, for example, you can say take this 2 by 2 kind of matrix situations, means you have 2 time periods. One is the pre-treatment and other is the post-treatment, and there are 2 kinds of group. One is the treatment group and other is the control group. Okay, so what you do is you are trying to understand the difference in the outcome for the treated group and control group over the period of time, and then take the difference of the difference. So that's why this method is known as the difference in difference. Okay, so here in this first part, what you are doing here in the first part, this is the difference in the outcome in the pre and post for the treatment group, and this is the difference in the outcome for the control group, pre and post, and then taking the difference in these two. Okay, so you can say this is the difference in outcome for the treated group in pre and post. This is the difference in outcome for the control group in pre and post period, and then taking the difference between these two. So that's why what we can say, this is the difference and difference estimator. Okay, the idea is to correct simple difference before and after for the treatment group by subtracting simple difference for the control group. And this we can put even in this matrix of 2 and 2. Means here, if you make this kind of matrix of 2 and 2, then also you can understand it. Okay, then you may take these outcomes. That way also you can get the estimate of it. Okay, but this is very simple per se, and for that purpose what we can do, we can use this regression techniques also to understand this difference in difference estimator. To do it, we can just use this OLS kind of framework into that. Okay, this DD estimate is unbiased estimate of the effect of the policy change. If absent of the policy, the average change in outcome would have been the same for the treatment and control group. Means here what we are saying is, if you say this kind of figure, if you make, and you say this is the effect is going on, and at this moment you are introducing the treatment. Okay, so as a result, this is the outcome for the treated, and this is the outcome for the non-treated. And here what we are saying, in the absence of this treatment, both the groups have moved in the same way. That we are trying to say. Okay, okay, so using regression techniques also we can get this DD value we can get. Okay, and for that what we are doing here, this is the observed YIT, and then what we are doing means here we have these 2 time periods. If t equal to, if we can say the post policy t is equal to 1, otherwise 0, and we have these 2 groups, treated and control groups. We can say if there is treated group, we can say 1, otherwise 0, and then it is the interaction between these 2, time and group. Okay, and here this eta can measure this DD. This effect of the policy is the eta in this case. Okay, say here example of, you can say a few years back, Delhi introduced this odd even scheme. Okay, and if we are introducing this odd even scheme, so what is the impact of the pollution level in that? If we have to understand that question. So this is the pollution level observed in this period, pre and post period. And here this we are saying, if we say 15 days before policy and 15 days after policy, this is that variable, and this is the variable because this policy is introduced in Delhi but not in NCR. So in these neighboring towns, we can say this variable is equal to 0, and if this monitoring station in Delhi, we can say it is equal to 1. Sorry, and this is the interaction these 2 variables. So this eta may measure the impact of this odd even scheme on the pollution level. Okay, so here our main assumption is what? This parallel trend. Parallel trend assumption is that. So means here the assumption is that this monitoring station in Delhi and the neighboring cities in the NCR, in the absence of the policy, both have the same kind of trend in the pollution levels. This is the main assumption in the DD analysis. Okay, then there is the second variable approach, which is known as this instrumental variable approach. Instrumental variable approach, if we have to understand, let's go back to these equations. And here, what we are saying, this t, this t, this t variable, we are trying to say this covariance of t and epsilon is not equal to 0. So as a result, what we are saying, this t is confounded or it is endogenous. And of being this t is endogenous, that's why we need to introduce some kind of instrument for it. Okay, so the second approach in this, you can say, observational approaches, sorry, observational approaches is what? That is the instrumental variable approach. Okay, in identification strategy based on an instrumental variable can solve the selection bias problem. The key is to locate an instrumental variables. Here means we need to find a variable in instrument for this t variable. And this instrument, what here we are writing at z, this variable should be related to treatment variable, means this t variable. But it should not be directly related to your outcome variable, or it should be independent from potential outcomes. Okay, so that's why for this instrument variable, there are two conditions it should satisfy to be an instrument. First condition required that the instrument predict t after conditioning on x. Means this z variable, it should be related to your this treatment variable. And the second condition is what? This z is orthogonal to the unobserved determinants of the potential outcome. Means this covariance of epsilon and z should be equal to 0. Okay, but here what is the problems? This relationship between t and z we can easily observe, but this covariance of z and epsilon, it's difficult to observe, that's equal to 0. That is the main problem. Finally, here we should also note that there are host of more subtle issues related to instrumental variables. Two especially important are the interpretation of the instrument variable estimates when there is heterogeneity in the treatment effect. And these instruments are weak. These are the problems in instrumental variable approach, or we should be cautious enough when we are applying this instrumental variable approach. One is how to interpret those estimates related to instrument, and second is if the instruments are not proper, if they are weak, there is some degree of biasness into that. Okay, and the last approach in this is what is known as this regression discontinuity design approach. Okay, so third approach is this regression discontinuity design, and the idea in this regression discontinuity design is what? What did happen? In the regression discontinuity design, is idea is what? Idea is that you say that those who are getting the treatment, to get this treatment, there is an incentive, or you can say there is something, you can say some kind of ability, kind of instrument is there. For example, say if we are talking that these people who get loans, they need to satisfy a certain conditions. For example, say in this agriculture loans, what you say that only small farmers can get the loan. There what you put the conditions that this land size should be a small proportion of that, a small plot size in that. Those who have that small plot size, only they can get this. What did happen?
सर स्लाइड आगे नहीं जा रही क्या? कोई प्रॉब्लम है सर?
There is something, yes. Okay, let me explain otherwise.
Yes sir.
Means I'm talking about this regression discontinuity design. In the regression discontinuity design, what is the idea? Idea is that this treatment is given only if a certain condition is satisfied. For example, say in this vaccination case, there what we are saying, this vaccination, the person can be vaccinated only if the age of the person is 60 or above. That kind of, hypothetically I'm saying 50 or above, those kind of ability you are considering. If the person is one day less of this 50-year age, the person cannot get vaccinated. If the person is 50 years or 50 years above than that, the person can be vaccinated in that. Okay, so in that sense, what we are saying, for all these persons, there all these other characteristics except this age factor of one day, all they are the same. So in that sense, how this effect those who are vaccinated or not vaccinated, how it differs from that. That difference we can say it measures this policy impact of the vaccination. Okay, so here what's your idea? Idea is this ability is there. You are putting this age. If the person is one day less of this age, the person cannot be treated. If the person is of that age or above than that, then the person can be treated. So here, again, what you are trying to do, you are trying to make this selection on observables, that term you are trying to make it zero. Means this all other things remaining constant, that you are trying to ensure. Okay, but here the problem is what? Problem is that in this kind of approach, your bandwidth is very small. So that's why here this simple OLS kind of estimations is not applicable. They will provide biased estimates. So here either you have to take this local regression
I,
just an very small introduction to these quasi-experimental approaches. Okay, so thanks. So now we
yes,
can
sir.
talk about the questions outside.
Okay, sir. We'll just take up the questions now, sir.
Yeah.
There is first question by Sharan Madhu ma'am, that in control group, how we will get difference for DD collection calculation?
In DD, difference in difference estimator.
Yes.
Okay. So in difference estimator, what we are saying, we have these two groups, treatment group and control group. Okay.
Well, so in she's asking that in control group, how we will get difference for DD calculations?
Yeah, that's I'm telling you.
Yes, sir.
Here in this 2 by 2 matrix, as we are talking about, and we have taken this example of odd even scheme. Okay, so in this case, our treatment units are what? You can say this monitoring station in Delhi, because this policy was for Delhi only.
Yes, sir.
But in these neighboring cities like Gurgaon, Faridabad, or you can say Ghaziabad, Noida, they were not under policy. This policy was not there. So those cities we can treat, monitoring station in those cities we can treat as control units. Okay, so we have these two periods, one is before and one is during the policy. So in the control, the difference before policy period and during the policy period. Similarly, difference between before and after in these Delhi cities. Okay, the control units are these neighboring cities, monitoring station in neighboring cities. The difference in pre and post that we can take.
Okay, sir.
Okay.
So, sir, basically, like we can have that differences in DD calculation when we are considering the pre and post any event period or something that it is
Yes.
there. Yeah. So another question is that which approach is more suitable for measuring the impact of government social welfare policies like midday meal or any other policy?
Look, here we talked about these two kind of approaches, experimental and this quasi-experimental approach.
Yes, sir.
This experimental approaches, generally these kind of approaches are adopted before the implementation of the policy. So there you conduct some kind of experiments, then try to understand the efficacy of the policy on this pilot group, and later on based on that you try to generalize it. Okay, but if the policy is introduced already, in that situation, rather than these experimental approaches, there this quasi-experimental or this observational approaches, they may be more applicable.
Okay.
Okay, within these approaches, there you can, given your data and given the policy question, either of these three approaches you can apply.
Okay, sir. Another question is by Nirja ma'am that, sir, can you please write the entries of the matrix of DD estimate if it is possible?
Yes, we can do that. Okay, so here just let me how we do. The slides are not moving.
Sir, we have lost you. My apologies for the disturbance in connection from time to time. It is because of the weather that is happening. I request all the participants to just bear with us. Sir will be back in a while. Ji, sir.
Yeah. So here, if we write this, just let me. Means you make this matrix 2 by 2.
Sir, it is not visible to us, sir.
Yeah, because the sharing is not allowed. Host disabled participant.
Sorry, sir. I'll just see.
Yeah.
Just let me check. Just, sir, give me a minute. Dr.
Yes.
Purushottam? Dr. Purushottam, I request you to please make sir the co-host.
Yes, ma'am.
Thank you. Sir, you can now share, sir.
Yes.
Yes, sir. Sir, your screen is visible now.
Creating problem in sharing. Yeah, I'm not able to share it properly. Okay, let me explain without writing.
Yes, sir.
Okay, so here what we can say, we have this 2 by 2 matrix. When you can say this horizontal, you may take either time or this group. Okay, or you say that this horizontal axis, you have these two groups. One is treatment group and other is the control group. T and C you can say. And on this vertical axis, you can say you have T0 and T1. Okay, so for in each cell, you can write the outcomes. Okay, then you can take this vertical difference between these two and horizontal difference also between these two cells, each of these two cells. And then you take overall difference in that. Is it okay or no?
Ji sir, explanation is okay. Kuljit ma'am, sir is not able to share the things that he is writing. Therefore, you just like us, you can only see the slide that is being shared by sir. So next question is by Krishna Kumar sir. He's saying that are we just projecting the D is equal to 0 outcome on the basis of past values or how?
No, means what we say, as in this initial figure, in common what we do, we try to compare these pre and post figures.
Okay.
In general perception or this media reports, they do that. For example, say in this odd even scheme, in the media, what they reported, what is the average pollution level in the week before the introduction of the policy? What is the average pollution level during the week during the policy? They used to compare that within Delhi. That's wrong. That's not D. Okay? Because even in the absence of the policy, there might have been the change in pollution levels. And those differences are not capturing those kind of changes, which could happen even in the absence of policy. So that's why in that equation, we are writing two terms. One is the difference in expected value of the outcome for the treated, and other is the selection on observable. So our objective is to make this term selection on observable equal to 0 rather than D. If D is equal to 0, that means there is no impact of the policy.
Okay. Sir, there is another question by Devinder Kumar, sir, that, sir, this explanation, is it related to simultaneous equation model, sir, in some way?
Yes, some way, not directly, but there is difference.
Okay.
Generally, the objective of simultaneous equation models is to understand the structure of the model. But here, objective is not to understand the structure of the model, but the objective is to establish causal relationship.
Okay.
And there, in this framework, we are trying to isolate the effect of the confounding factors. That is the difference.
Sir, the next question is by again Krishna Kumar, sir. He's asking that are there no hazards in using this RCT, which was used in vaccine related studies, to social policy evaluation where many variables enter in different social settings? So, sir, basically, he's saying that when we are evaluating the different social policies where a number of variables are entering depending upon the different social settings, is it not, are there going to be any hazards in using this RCT?
No, in RCT, as we said that, there are these ethical questions are there. Okay, means are you explaining the outcomes to the people before bringing them under treatment or not? If you are explaining all those problems to them in a true manner, where if they are participating, are they biased with some other variables or not? So these are the concerns in RCTs. So these RCTs always they face this kind of questions. Okay, but per se, if the objective is just to understand the policy impacts, then obviously what we are saying, there are heterogeneity. This heterogeneity is creating this selection on observable part. And that by controlling all these other characteristics, we are trying to hold constant all these other variables. That we can do using this quasi-experimental approaches.
Okay, sir. There is one last question by Sheetal Gadekar, ma'am. She is asking that what is the difference between indirect OLS estimation and the method of estimation discussed here? So these are more or less like Devendra Kumar was, sir was saying whether it is similar to simultaneous equation model. Ma'am is asking here that to what extent this method is similar to indirect OLS estimation, sir.
Look, in this OLS, what we do in conventional sense, there there is a dependent variable, this y, and we say this y is the function of certain variables. Okay, and there our objective is what? Objective is trying to explain the variation of y that is explained by the variation in this x variables. Is it right? That's our objective in OLS. Okay, so there what we do, there is r square we use as we are introducing one more variables. How this r square is affected by that? This kind of approach we take in this standard OLS. In this standard OLS, what more? We have these assumptions of, you can say, normality, independence, this kind of homoscedasticity. These all assumptions are there. Okay, and here main assumption is what? This covariance of x and error term is equal to 0. That's our main assumption in the OLS. Then we can see this exogenity assumption is there. Okay, but here, what is the difference? Difference is that this exogenity assumption, rather than we say it is an assumption, we are trying to assure this relationship.
Yes,
In
sir.
standard OLS, we say this covariance of x variables and error term is equal to 0. This assumption we take. Okay, but here what we say, rather than this assumption, we try to make that it should be there. This covariance should be 0. We are not making it by assumption, but by design we try to do it.
Yes, sir.
This is the main difference. And if we can make it by design, then we can say there is causal relationship between x and y. Otherwise, no. This is the difference.
Okay, sir. So with this, we come to the end of the question answers. Sir, I'm not finding any more questions which have remained unanswered from your side, sir. So with your permission, sir, can we conclude the session, sir? Sir, can I conclude the session with your permission, sir?
Yes. Go ahead, please.
So, thank you, sir, for giving an insight into a new method of estimation for the purpose of program or project evaluation, as is being discussed by sir in his presentation. It has definitely added to our knowledge of how we can use or find the impact of different policies by using this method of estimation, sir. And definitely the way you have answered the questions relating to like how it is different from conventional indirect OLS estimation or simultaneous equation model and other explanations that have been done. We are really thankful to you, sir, for the same. And I, on behalf of TLC Center Ramanujan College, on behalf of Indian Accounting Association, and on my own behalf, sir, thank you. And I'm highly grateful that you have just found some time from your busy schedule to share here your ideas and your knowledge regarding this topic. Thank you, sir. And a very good afternoon to everybody, sir. With this, we come to the end of the session. Thank you.
Thanks a lot to everyone.
Thank you, sir. I request all the participants to be on a lookout. We'll be releasing the last assessment at around 1 o'clock, and that is going to be kept open for 12 hours. That is what is our policy is. And besides that, I also request that all the participants must join the validatory session, which starts at 2 o'clock, and it is compulsory for everybody to be a part of that validatory session. Thank you.
Yeah, thanks a lot. Thank you. Thanks a lot.
We will come back for the validity session at 2 o'clock. Thank you.